Next project is Smart Hand Tools, Building the Future of Work with Ethical AI. And the project members presenting will be Chelsea McCullough of the School of Information and Rachel New of the Walker Department of Mechanical Engineering. And they'll be presenting AI is not going to take our jobs, supporting skilled trade workers with smart hand tools.
Hello, everyone. It's really nice to be a part of this symposium and to showcase our work. My name is Chelsea McCullough. I'm a third-year doctoral student at the School of Information, and my colleague Rachel New and I will be presenting on Smart Hand Tools project. AI is not going to take our jobs. So we are very fortunate to be a part of a talented team, many of whom are here in the room and many of whom I know you all have had lots of great conversations both about our project and about just the interdisciplinary nature of research. I really appreciate being able to walk the talk of interdisciplinary research. We meet and we talk constantly, not just in terms of project updates, but really considering the challenges of our project as we're trying to develop smart hand tools. So as some of you may be very familiar with our Smart Hand Tools project, and some of you may be relatively new. So we wanted to start off first by the guiding research question that has inspired our work, which is how can we co-design AI to support, underline and bold support, not replace skilled trade workers. And just for a bit of context, skilled trade workers are those workers who use tools and machinery to accomplish their jobs. The literature uses other terms such as blue-collar workers, which might be a bit more colloquial, or middle-skill workers. And we're extremely fortunate to have three really solid partners in this work, both City of Austin, and thank you, Charles Perma, for being here, ACC, and thank you, Troy DeFreites, who's here from Austin Community College, and also the Texas AFL-CIO, which is the state-level trade union, labor union for the state of Texas. So our work is really centered around the development of specific prototypes for smart hand tools. And you see two different categories of tools here. One is the power hand tools. So you can see a drill here, and then you can see a rotary tool. And these prototypes, are tools that anyone can go to a hardware store and buy. The skilled trade workers that we have the opportunity to work with, they use commercial grade tools, so I think it's an important distinction that their tools in the field look slightly different than the ones we're using, but our job here is to work with them to understand what is important to them in their work and then develop prototypes for smart hand tools. Another important thing to note about the prototypes mentioned here or shown here is that there is a kind of sensor box attached to these tools. And I'll describe a little bit later, how we're co-designing this with our participants who are skilled trade workers and instructors and supervisors in each of the three partners that I mentioned before. But that was an important distinguishment or piece of information for our engineering team who thought, we could embed this kind of smart hand tool technology within the tools, and the workers gave us feedback that said, no, it's important for that sensor box to be basically owned and controlled by us, and those tools are used differently in different fields with different teams for different processes, and so having that sensor box be attached to the tool is one of the important insights of our team. Also, you see a welding simulator here, and some of you may remember, if you were here for the last Good Systems Symposium, our colleague Carlos Salazar did a really beautiful presentation of a virtual reality welder, and Tina Lassiter is also really a wonderful researcher on this work, where people who are not quite so accustomed to welding can go through a virtual simulated process in the work of training and learning how to use welding tools and how to become more familiar with welding tools. So I've mentioned just a little bit about our partners, but this is an incredibly important part of our work. We embed within these different teams at Austin Community College, the City of Austin, and the Texas AFL-CIO. With Austin Community College, Tina and I had the opportunity to actually go into the classrooms, to be in the welding units, to put on welding helmets and see the sparks fly. It was really, really cool, not just to observe, but also work alongside with these students and with the instructors. So you can see just a list of the different qualitative research methods that the social science team did, from semi-structured interviews to validation studies, of course, surveys, demos, prototype tests, some take-home tests, and lots of validation studies, and now we're moving into surveys with the Texas AFL-CIO. With the City of Austin, we've been really lucky to work across 5 different departments: Parks and Recreation, Fleet Mobility Services, Austin Water, Watershed Protection, and the airport. And we're following up on research to both, or opportunities to both work with the City of Austin's fire department, so the research is ongoing. And with the Texas AFL-CIO, with the different labor unions, we've worked across 4 different groups: iron workers, insulators, sheet metal workers, and plumbers and pipe fitters. So I really appreciate, and I hope that you all can understand the diversity of skilled trade workers that we're being able to interact with and that we're able to learn from and co-design these smart hand tools. So our work, of course, is multidisciplinary, and we're co-designing, as I mentioned, with our participants. This is an iterative process, and we work back and forth between the social science team and the engineering team and the participants that we're working with to co-design these tools. So the themes that have emerged from our qualitative research are 3 core themes, and these are consistent across all of our partners and across all of the many different skills and perspectives of our participants, which is, number 1, safety is a priority. That definitely came through in almost every single interview that we've done. And you can see the participant quote here saying that, safety is incredibly important, and they talk about the impact of bodily harm to the dangerous nature of skilled trade work, where the participant mentions carpal tunnel in both of the participants' hands, and how data from a smart hand tool could help say, maybe don't hold the tool quite so long, or use this tool for 1 minute and then take a break, or use this tool with a different angle, and perhaps that might reduce the bodily strain on workers. And there are many, many, many examples. I invite you all to read some of our research in our papers, which I'll mention a long list at the end of the presentation, on different ways that safety is considered by our participants. And then, of course, training. We definitely saw this through the welding simulator, but also with powered hand tools, where the participants saying, hey, data from a smart hand tool in real time could be like a work partner. This is giving the worker feedback in real time about the nature of their work, which is a dangerous nature of their work. And then finally, the quality of work. And when I mention quality of work, this theme basically talks about the proper use of using a tool. A lot of times these workers are in very dangerous conditions. This is very technical work. This is very dangerous work. And they're making really important decisions on the fly. Perhaps they're having to squeeze into, tight conditions or a tight space, or they're up in a cherry picker adjusting electrical lines. And the quality of work is incredibly important, not just for how well that work is performed, but also how safe that worker is in performing that work. So in terms of how our teams work together, we've worked really hard to develop these prototypes, and now we're moving into the stage which is well established, and Rachel will go through and detail more of her findings here, where we're working with algorithms to not just develop the prototypes, but also the data coming off of those tools. A lot of times, we're working directly with workers in the field and with our partners to test out these prototypes and develop these prototypes, but when it comes to developing the algorithms, it's first important to test with students in the lab, and then our next phase will go out back into the field and work with our participants around 3 different important activities, which is activity and task detection, which Chela will explain more, expertise detection, how expert or novice a worker is or a trainee is, and then finally skill detection retrospective to the feedback to improve their work. So Chela will provide all the fine-tuned details and technical aspects of how we're doing this in the field. Thanks.
Hi. So in our study, we developed a prototype on a rotary tool where we attached a sensor box with an IMU and a current sensor. We also attached a low-cost camera to a face shield and then had the participants wear the face shield so we could see what they were doing with their hands while they were using the tool. We then supplied participants with 2 different tool bits, a sanding and a cutting bit, and had them complete tasks. And the goal of the study was to use the sensor data we collected while they were completing the tasks to determine their level of skill. So for the actual tasks, we asked them to cut out 3 different shapes with increasing complexity, and this was to allow for more skill expression from the users. You can see if we compare the expert and novice shapes, the expert cutouts fit a lot more snugly with the shapes than the novices do. We needed to actually quantify this though, so we used some industry standard methods and basically took the outline for the shape and then bounded it from the top and the bottom with the actual desired outline without any intersection between the outlines. And then if this distance between the 2 bounding shapes was very large, that meant the cutout didn't fit in very well, and therefore the user was a novice. And if the distance was very small, then the fit was very good and the user was an expert. So using this method, we were able to take the end product of all the users and come up with an objective measure for their skill, which we were then able to compare our later machine learning algorithms with. So our data analysis started by developing 3 different metrics, which we personally decided were a good measure of skill for this specific task. So the first one was speed, so how fast a user can complete a task. The second was energy consumption, how much energy they consumed while doing the task. And the third was economy of movement, so how much they moved around during the task. We plotted these in some radar graphs in a way where a larger area in the radar graph indicated the user took a longer time to complete the task, used more energy, and also moved around more. You can see from our plots here, the top plots are the experts and the bottom plots are the novices. And you can see the novices tend to have a larger area. We also extended our economy of movement analysis to vision data. So we did hand key point detection and also background key point detection, and we were able to use these as a proxy for determining the user's hand position relative to the part position at all times. And we were able to perform the same economy of movement analysis using just vision data and came up with similar results. The problem with these initial forms of data collection or data analysis was that we personally had to come up with the tasks for the metrics for this specific task, and those metrics could change depending on what tool task you're actually performing. So we wanted to develop a task-agnostic approach that could be generalized between maybe different tools. So we implemented 2 different machine learning algorithms, one supervised and one unsupervised. And we fed the machine learning algorithms the same sensor data, and we had them output their estimate for what the skill of each user was. As you can see from the table, aside from one outlier, they both did a very good job of distinguishing between expert and novice users. In addition, within the novices, they did a good job ranking the novices correctly. But for the experts, the machine learning algorithms did a very poor job, and we determined that this was because there was a lot smaller variance between the experts' data than in the users, the novices' data. And so if we wanted to improve the accuracy of the algorithm for the experts, we would first need to take a lot more data, and secondly, we would need to focus more on taking more expert data to kind of be able to better understand because it's the less variance there is between the expert data. But in conclusion, we have some preliminary results that show that we can distinguish skill with machine learning algorithms, and therefore in the future, we might be able to, in real time, give user feedback before the actual part is completed. By then it's too late, the part's already done. So we might be able to help people improve. Thanks.
So one of the things that I really appreciate about working with Chela and the entire engineering team is that they make incredibly complex things. They are able to translate that into language that we can all understand. So I know we had the benefit of just going through a couple of slides, but it has been so awesome to see this work develop over time, and just the level of expertise and technical ability that they have to take things that have not been done to go from developing a product and really talk about developing a process that can make a difference in the lives of skilled trade workers who build the world all around us. So our process, and we're all on the same page, whether we're social scientists or we're engineers, that there are, of course, machine learning algorithms and there are technical tools. There are smart hand tools that can support the human, but the human is never out of the loop. In fact, it is the machine that is in the human loop. And we're actually on the same page as well with our participants, as you can see from one of our participant quotes who says, yeah, you can overthink things as a human, and that's when data can come in to support you in making decisions a bit more quickly. But at the same time, there's nothing like a human at the helm to make those decisions. So a bit of a left turn, we are working with the AFL-CIO, the union members, as I mentioned, to really understand how they consider AI in the scope of smart hand tools and how they believe that this will impact their jobs and a lot of the fear that's around AI, around job automation. So we're in the process right now of we've conducted surveys with 4 of the groups that I mentioned, the labor unions, and now we're doing follow-up semi-structured interviews. And this slide here focuses on one of the questions in our survey, which is what effect AI will have on the number of jobs in the US versus the number of skilled trade jobs. And I think this is a really important finding and something for us to consider as we all think about what is the impact of AI. Skilled trade workers are actually less concerned about their specific jobs, their skilled trade jobs, than jobs overall in the US. And as most of us are knowledge workers, I think we kind of default to jobs overall, and I think it's really important for us to consider that this is not the case for everyone, and it is the physical, handheld nature, the hand-to-hand nature of skilled trade work that they believe, no robot is going to take my job. My work as a skilled trade worker, which is highly technical and highly skilled, is perhaps protected, and maybe AI can augment that work and support me in that work, but it's not going to take my job. And here are just 2 quick quotes as we wrap up on AI's impacts on skilled trade jobs, where one worker is saying, hey, AI is not going to replace me, what we do in our trade and what we do in the field. And then another worker saying, I don't have to worry about AI entering our field, putting AI in physical form and then letting that form work. And it's interesting, to think about the work that was presented in our first case around robotics and where robotics is right now, where skilled trade work is right now, and where that will be in the future. So I think that underpins the importance of this research and the importance of our work. And in concluding, I just want to iterate some of the points that we've made in our presentation, that our job as researchers here and in this interdisciplinary team is to enhance training, to broaden participation in the skilled trade forces, in the skilled trades. There are more skilled trade jobs and there are workers to fill them. And yes, that has economic consequences for us here in the US specifically, but it also has some pretty serious social consequences. So that's a big part of our research and what motivates us as a team. Of course, improving worker safety while people are doing jobs to reduce accidents and avoid injuries. And also the prototype development and the sensor box addition to the team, I think is really, really cool, where workers are expressing that it's important for them to maintain ownership of their data, and the machine learning algorithms that Chela and the engineering team are developing are supporting all of that work. So again, a huge thank you to all of you for listening. A massive thanks to all of our partners who work very close and collaboratively with us. Here's a list of our publications publications and output, as I promised earlier before, and we'd love for you to learn more about our research, and here's a QR code for you to do just that. So we look forward to your questions, and thanks for your attention. Yeah, please, thanks.
Okay, so I don't know how to phrase this question, but personally, like, I don't want to have to work out of necessity. Like, I just want to choose to work, not like from money. So the title of the talk was very interesting. Like, it's not going to replace our jobs, because some people kind of want that. They want like their economic safety to be protected. So did you ever consider that perspective?
Yeah, thank you for that perspective. I think that's a really good one. So one of the questions that we ask in our survey and in our semi-structured interviews with workers is, what is one aspect of your job that's most important to you? And a lot of times the feedback is kind of it fits in two camps. One is, I'm proud of the work that I do, and I love going to work every single day because I'm a part of a long legacy of skilled trade workers. A lot of them talk about, not to be gender specific, but I'm talking about the data. My dad was a fill in the blank. My dad was a welder, or my dad was a linesman for 30 years, and now I'm proud to take that spot and continue that legacy. And so that's the feedback that we hear a lot. And the other is, I got to make a living and feed my family, and this is such a great way to do it. I can be out in the field. I love working with my teammates. It's a real positive aspect, or a lot of positive feedback about doing work. So I think, speaking as a knowledge worker, I haven't always had that kind of sense with my work when I'm stuck in a desk just having to do things every single day. So it's an interesting thing for us to think about. It's just the juxtaposition of skilled trade work versus knowledge work. Yeah, thanks. I don't know if you want to. Okay. Yeah.
Chelsea, Craig Wheeler from Astronomy.
Yeah, of course, Dr. Wheeler, nice to see you.
I wanted to kind of follow up on your very last comment, because I didn't know you were going to make that comment. So the whole smart tools thing is a brilliant, healthy program, working with the trade stuff. But when you say AI is not coming for our jobs, and maybe you're kind of alluding to this now with the knowledge workers, but aren't you a little afraid that AI is coming for white-collar workers, even CEOs?
Yeah.
It can strategize, it can think, it can lie. There's all sorts of things.
Yeah. I like the mention of lying. That's an important thing for us to think about. For me personally, as standing here as a human being on a stage in Austin, Texas, yeah, I'm real concerned about that. And part of our data too, specifically with the labor unions, talks about their thoughts around the general use of AI versus the use of AI for the skilled trades. So we're really focused on their roles as skilled trade workers and how that impacts their jobs and their perspectives in the skilled trade. So that's where we spent the majority of our attention, but we'll be publishing papers very soon on the more general nature, so hopefully we'll be able to discuss those with you. Thank you for your question. Okay, great, thanks.